Okay, hello and welcome everyone. So in this video, I'm going to do some second degree price discrimination problems and then like a Oligopoly Stackelberg type problem. All right, so I'm going to start off with a second degree price discrimination problem. With second degree price discrimination, we have a couple of consumers and we have a product that can be sold in a couple different varieties. And the idea is that each consumer buys at most one version of the product. So this would be like, you could think of like Tesla, right? So you could buy the short distance Tesla, or you could pay more and get the long range Tesla. It's the same car with a different line of code that's added. So anyway, but right. Marginal cost to produce the low quality version is $10. The marginal cost to produce the high quality is $15. We're not talking about Teslas anymore. We have consumer type A, consumer type B, and we have 100 of each type. Suppose you were only to offer the low quality version, find the optimal price and profit. Suppose you're only offering the high quality version, find the optimal price and profit. Suppose you offer both, do the same thing. So if we're selling the low quality and only the low quality, we have to check, do we want to sell at the price of 35 and sell to 200 people? Or do we want to sell at the price of 40 and sell to 100 people? Well, there's a small difference between 35 and 40. We probably actually would rather have like 70 in revenue than to get just 40 in revenue. And so here the optimal price is 35. Profits are going to be 35 minus 10 times 200, or 25 times the 200, or 5,000. If we want to sell the low quality. What if you sell the high quality version? Well, if you sell the high quality version, we could sell at a price of 45 and sell the both, sell 200 units. Or we could sell at the price of 70 and sell 100 units. Here it turns out the optimum price is 45. The profits are 45 minus 15 times 200 is 6,000. Suppose we decided to sell at the valuation of our type B consumer. Suppose we decided to sell at price of 70. That's good. We would get, what, 70 minus 15? We'd get a markup of $65 or $55 over those 100 units, which would be 55,000. However, that's not as good as if we sell at the lower price to both. Okay, what about if we want to sell both versions? So we want to sell both versions. Remember, with second degree price discrimination, there's kind of three things we need. First is we have to recognize that we are presenting the same pricing scheme to both customers, and they are just picking whichever one's right for them. That being the case, we have two things that can go wrong. We could have our type A consumers, they're our low valuation consumers, just like not buying. Or we could have our type B consumers just buying at the low value or at the low quality price, right? And not paying their maximum. So we want to guard against those two things. To prevent our type A consumers from not buying, we don't want to set a price any higher than 35 for the low quality. Well, that's obvious. So we'll set price of low is going to be 35. Type A consumers will buy low quality. Our profits are going to be 35 minus 10 is 25 times the 100 units, right? That's this right here. What about for our high quality? Well, you might think we want to set the price of 70 because that's what the type B consumers are going to pay. What happens though? Remember, everybody gets to face the same prices. And so if our type B consumers see that price of 70 and see that price of 35, they're going to say, wait a minute, if I buy high quality at a price of 70, my consumer surplus is 0 because my willingness to pay for high quality is 70. If I buy low quality at a price of 35 and I'm a type B consumer, my consumer surplus is 5 because here's my reservation price. Here's my willingness to pay for low quality. I would pay 40. I'm being asked to pay 35. I'll just do this. I have $5 of consumer surplus. Remember, both consumers see both prices. Similarly, our type A consumer sees this price that we're offering for the high quality item. And if it's anything over 45, they're not buying it. They're going to buy low quality instead. The highest price that we can offer our high quality product for, such that consumer B will still buy, is 65. At 65, they're exactly indifferent between buying and not buying because they'll get $5 a consumer surplus if the price we give them is $65 and this is their willingness to pay. So other sort of good, reasonable, acceptable answers would be like $64.99 or $64 maybe. Bad answers would be like selling the high quality version low enough that you'd rather just sell them the low quality version. So, okay. So profits are going to be 35 minus 10 times the 100 that are buying. So our consumer type A are going to buy low quality and pay $35. Our consumer type B, our profits are going to be 65 minus 15, higher marginal cost to produce high quality, times the 100 that are buying. And then our profits are going to be overall 7,500. All right, here's another one. So suppose you have the option to produce different versions of the product, high quality or low quality. Marginal cost of low quality is 5. Marginal cost of high quality is 25. Two types of consumers, 100 of each type. Suppose you only offer the low quality version. Suppose you only offer the high quality version. Suppose you offer both. What do you want to do? Okay, so if we're selling only the low quality version, we have to decide, do we want to sell at a price of 25 and sell that to 200 people, or do we want to sell at the price of 40 and sell it to 100 people? So I say here the optimal price is $25. Profits are 25 minus 5, which is 20 times 200, which is 4,000. That's better than just selling the low quality to the high evaluation consumer. Instead, the profits there would be selling at a price of 40 minus our cost of 5, which would be like 35 times 100 to 3,500. All right, so we're better off selling the low quality version to both consumers if that's all we're selling. What about the high quality version? We could sell the high quality version at a price of 50 to both, or at a price of 120 just to our type A's. Here are the optimal prices, you might guess, because these are pretty different, 120 and 50. Here the optimal price is 120. Profits are going to be 120 minus the marginal cost times 100, 9,500. That is better than selling high quality to both consumers, where the profits would only be the 50 minus the 25 times 200, 5,000, right? All right, what if we're selling both? The optimal price is going to be $25 for low quality, $105 for high quality, not $120. We'll set the low quality of 25. Our type B consumers will buy low quality. But our type A consumers see that price of 25 for low quality. They would get consumer surplus of 15 if they were to buy the low quality item, because this is the most they would pay. We're quoting a price for everyone of 25. So our type A consumers will buy low quality if their consumer surplus from low quality is higher than their consumer surplus for high quality, which means the most we can charge for high quality is 120 minus the difference between these two numbers, which is 105. So we'd say the optimal price is $25 for low quality, 105 for high quality, not the 120, because then the type A's will buy the low quality instead. So the profits are going to be 25 minus 5, or 20 times 100, plus 105 minus 25 times 100. Profits are 2,000 plus 8,000, which is 10,000. All right, and the last one, we've got roommates developing competing versions of a new technology for which the marginal market demand is given here. Both face constant marginal cost of 30. We don't quite have symmetry because quantity 1 is being viewed differently by the market than quantity 2. This is like measuring some amount of product differentiation. So for the Cournot oligopoly equilibrium, Stackelberg, and then comment. So for Cournot, let's write out firm 1's profits first. So this is just demand. And what did I do here? So I do not want this square here yet. Do I? No, I do not. So I want this just to be the inverse. I just want this to be inverse demand. This. I'm going to distribute this through, and I'm going to get 150 Q1 squared. I'm going to get 2 minus 2 Q1 squared. And I'm going to get Q2 Q1. So this first order, let me just verify this first order condition. Is that correct? This will be 15. 150 minus 30 is 120. Q1, take the derivative. Yep. This is going to be after we've distributed. Yeah, after we've distributed this will be 2Q1. Oh, I know what I did. See what I did? Here I was too clever. I distributed here. I distributed there. And then I put this parentheses there. So I probably what I was thinking is I want to leave in this grouping because This is the revenue portion, and this is the cost portion. All right, so how do we fix this? Let's just pretend this doesn't exist, right? Okay, and now let's check this. Let's check this first order condition again. So let's see, we'll have 4q1 minus q2. Yep, that's all right. Okay, so firm 1's reaction is going to be 30 minus 1/4 q2. Because solving for q1, we will have 120 minus q2 over 4 is equal to q1. Yep, so 120 divided by 4 is 30, and then 1/4 q2. Yep. And we got to solve the problem from firm 2's perspective. Again, this is even worse because this q2 shouldn't belong here, right? This is fine if this q2 isn't here, or if we get rid of this and put a square there. No, sorry, get rid of this and distribute this and then put a square. Whatever. So this, what should this actually be? One of two things. So it should be 150 minus 2q1 minus q2, that whole quantity times q2. Or it should be 150 q2 minus 2q1 q2 minus q2 squared minus q2. So the first order condition, let's check this and make sure this is right. This is correct. You're going to get a 2q1, that's right. And then this is q squared, so it's going to be 2q2. That's correct. Yep, that's right. So our firm 1 for 2, that was just obnoxious. Firm 2's reaction is 60 minus q1 is equal to q2. Solving our system of reaction curves, so replacing 60 minus q1 into firm 1's reaction, right, for this. We end up getting 30 minus 1/4 times this stuff. And so this is going to be 30 minus 1/4, so that's 30 minus, so that's 15 minus 15 plus 1/4 q1. And so we're going to end up getting, so 30 minus, so 15 minus 1/4. So we end up getting q1 is going to be 20, and then q2 is going to be 40. Let's verify. So let's plug in 60 minus 20 is indeed 40. And then over here, 30 minus 10 is indeed 20. Yeah, that's correct. So price is going to be 70. That's coming from 150 minus 2 times 20. So, or 2 times, 150. So that's 110 minus 40 is, it's like 11 minus 4 is 70. Okay. And then profits are 800 and then 1600. All right. So let's do Stackelberg. So Stackelberg is going to start off with firm 1's profit function. If I wrote that correctly, it's going to look kind of like this. 150 minus 2q1 minus q2. But instead of q2, I'm going to write q2 as a function of q1. So I'm going to have 60 minus q1, right? Minus 30 q1. So simplify or distribute this q1 and then get the first order condition. So that's going to be 60 minus 2q. This is terrible. 2q1. And so we end up getting 30 q1. And then let's see, we end up getting q2 is equal to 30. Why? Because q2 is going to be 60 minus 30 is 30. All right, so price is 60, and then profits are going to be 900 for each firm. What's going on? Well, firm 1 is weaker relative to firm 2 in terms of what the market will bear, right? Each additional unit of quantity 1 is going to reduce the market price by more than each additional unit of quantity 2. So firm 1 is actually able to level the playing field by moving first. And so put differently, firm 2's unusual strength enables it to nearly overcome the disadvantage of being the Stackelberg follower. It's kind of two ways to look at it. Firm 1 is weak. If they move first, Stackelberg leader has an advantage, and that kind of helps them. Or firm 2 is able to, Stackelberg follower is usually pretty weak, in a weak position relative to firm 1. But here, being the Stackelberg follower, firm 2 is so strong, they're nearly able to overcome that disadvantage. So, okay, very good. So, go ahead and conclude here.